Hi Chang, I came as fast as I could. How can I help you today?
Hi Manfred, how good of you to come. My boss wants me to optimize the build time. He says we are not productive enough and that our competitor, Three-Dimensional Delight, follows closely, so I need to find out where time gets lost. But how can I find out?
Well, did you know that EOSPRINT offers quite some possibilities to analyze the building time and to optimize your jobs?
Really? That sounds interesting. Can you show me these features?
Of course. Let's go right into EOSPRINT and I will show you 3 ways of analyzing the build time. Here we are. This is the Preview tab of EOSPRINT. From here I can explain everything to you. These are the 3 functions we will look at: the classic build time calculation, the analysis of the laser workload, and a close look at all accruing times in detail. The first way is the classic building time calculation. After the build time is calculated, which can take a few minutes, you see the total building time, split up in exposure time and recoding time. You also see the exact start and end time of the build job.
This is very nice, but I really want to know where time gets lost.
Just a moment, you will learn more about this when analyzing the laser workload. Comparing the laser workload, you can see that laser 2 and 3 have a higher average workload than laser 4 and 1.
Wait. How do you know that?
You can recognize it by the area occupied by lasers 2 and 3. Lasers 1 and 4 are not even used for the last layers.
I see. I can imagine that it would help to arrange the parts differently.
Yes, that could be one measure. You can scroll through each layer to see the exact exposure times. This information can help you to optimize the job, for example by rearranging some parts. Clicking on this button opens the diagram in an extra window. All exposure times can be exported per layer in CSV format. Third, as of EOSPRINT version 2.12, you can analyze your job in a very detailed way. Under Layer Info, you can see how much time is spent, not only on the part hatching and contour, but also on supports, edges, laser jumps and delay times. But mind you, all these times are related to the layer that the slider control is currently located.
This is really interesting. I remember that many of those exposure types are depicted in the preview function.
Yes, you find most of them when using the preview function. The contour line, for example, is blue, the hatching is green, and in the picture you can even see the down skin, which is black. Here you can activate the display of laser jumps, and this gives you a good impression that quite a lot of time is spent on laser jumps.
Yes, I see. I think this would be one lever to start with.
EOSPRINT also offers tools for time optimization, but this would be another video.
Well, for now I am happy that EOSPRINT offers such good tools to analyze the building time. And I will surely be back for more. Thank you very much. Stuart, we have made great progress. The build time analysis in EOSPRINT helped us to optimize our jobs. In some cases we saved 1 hour per job, in other cases even more. If we save just half a second per layer, it's about 1 hour and a half for a job with a build height of 400 millimeters.
That's really great, Chong. What exactly have you done to achieve this time savings?
Mainly it was the rearrangement of parts that made a big difference. In some cases the laser assignment was optimized.
Interesting. So we can build more jobs next year. That gives us an advantage over Three-Dimensional Delight. Good job, Chong.